Okay, let's look at the pH and the pOH. Okay, so pH equals the negative log of the H plus or the hydronium ion concentration, and pOH equals negative log of the OH negative, the hydroxide ion concentration. Now let's say you're given pH and you want to calculate the concentration of the H plus. Well, you can do that by saying H plus, concentration of H plus ions, equals 10 to the negative pH. Okay, and for OH negative, it's equal to 10 to the power of negative pOH. Okay, so these are things that you need to know for this topic. Okay, you need to know these expressions here. And there's one more, and that's pKw. Okay, so pKw is equal to pH plus pOH. Okay, so what we've done here, we've had this expression here, which is the expression for Kw, the ionic product constant of water, and we've taken the log of each of these. So Kw becomes pKw, H plus becomes pH, and OH negative becomes pOH. Okay? Right, let's look at Ka and Kb. So Ka is the acid dissociation constant, Kb is the base dissociation constant. And the value of Ka or Kb tells you the extent of the dissociation of the weak acid or the weak base, because as you should know, weak bases and weak acids are partially dissociated in solution. Okay, so for Ka, let's look at this example here. So we have ethanoic acid plus H2O. Okay, and on the right side we're going to have the ethanoate ion plus H plus. Now to write an expression for Ka, okay, you put the products on the top, which is the ethanoate ion and the H plus, and on the bottom you put the weak acid. So in this case it's ethanoic acid. Okay, you don't have to put the water in there. So that's the expression for the Ka of ethanoic acid. And let's have a look at Kb. So for this example, I'm going to use ammonia, which is a weak base, plus H2O. Now the water is going to donate a proton to the ammonia to give us NH4 plus. And what's left is OH negative. Okay, so for the expression for Kb, at the top you're going to put the NH4 plus and the OH negative, and on the bottom you're going to put the concentration of the weak base, which in this case is ammonia. Okay.